So I'm going to go ahead and get started. I apologize in advance if you guys like lots and lots of slides with lots and lots of text. I don't. So they're mainly bullet points for me to talk. I like to talk a lot. So before really getting started, there's a couple of disclaimers. First is that these are opinions and they're mine. They're not my employer's, they're not anybody else's. If you don't agree with them, that's okay. I'm just a network person, so out of curiosity, are there any other people here that would identify as just network people? Cool, so a couple. Awesome. I'm not a very good one. This says sometimes, reality is probably most of the time. Kind of okay. I can work my way around config T and a couple of show runs. And there's a long way for me to go in general in a lot of aspects. And I think for the networking industry specifically, there's an incredibly long way to go. The systems folks have a good 5 years up on us from when they really started to where we figured out, hey, maybe this is a good idea. So to say that I'm a network architect at Sauce Labs really just means that I'm a point of escalation. I do our platform selection, so we happen to run a bunch of Cisco stuff, some other vendors, kind of my responsibility. Troubles get out of hand, they come to me, need a new platform for a new footprint, that's also my responsibility. I am a part-time coder. I have had the title of software engineer. I will never, ever call myself a software engineer. It's honestly really rude to the people who are actually software engineers. I can write for loops and if statements. It's about the extent of my software engineering. So this talk is largely an exploration of one possible solution. It's also a personal journey of what I've been through, what I've done, the things that I found that have worked, the things that I found that haven't worked. Again, it's my opinion. This is not an in-depth tutorial. If you came here to learn how networks work, this is probably the wrong talk and probably the wrong conference. Definitely not a network primer. So, as networking people, whether that's engineers, analysts, technicians, whatever, administrators, whatever the title happens to be, what we find a lot of times is that things go wrong. And they go wrong a lot, and it really sucks when you have to get paged. It's bad enough, during your 8 to 5, you get paged and you have to go fix something, and maybe there's a critical part of the business down, maybe there's not, but either way, nobody likes when things go wrong. For me specifically, there's not a first level of support at my company. So, kind of tongue-in-cheek, I am the knock. Something goes wrong. If it's my on-call rotation, there is nobody that gets called before me. And that's not fun. I've worked places that have knocks, and man, is it awesome. Because even when you're on call, you almost never get called because they have their stuff together, they have their run books, they can probably handle 90% of whatever issues come up. At my current employer, Sauce Labs, I don't have that luxury. Network monitoring is pretty bad. It actually kind of sucks. There's 4 basic mechanisms to monitor your network. The first one's SNMP. And I'll get into each of these and why they're terrible as we get further along. The second one's syslog, which I'm sure most people here are at least passingly familiar with. Streaming telemetry is another potential mechanism to monitor your network. And having active checks, so Nagios. I hate Nagios. I have not met a human being on this planet who says, I love managing Nagios. In fact, I've known people who get config management into their environments strictly so they can manage Nagios configs because they are a bear. When you've got 10 servers or 10 nodes, it's not really that big of a deal, right? 10 nodes, 10 checks. Maybe they all do the same thing, maybe they don't. But when you've got hundreds or thousands of nodes and none of them are the same type, or there's a wide array of different types of systems you have to check, Nagios can be cumbersome. And some people get around this problem with active checks by mandating that everything has to have a very specific endpoint that's like /health check. And so you write one Nagios check and all it does is ask /health check, and it's good, but not everybody has that luxury, and then not all third-party services that you have implement things the same way. You end up writing a bunch of checks. In networking, we don't have much, if any, in the way of automated remediation. Beyond homegrown solutions, which I'll talk a little bit about as well, I haven't actually seen a product besides StackStorm, which is now owned by a vendor and therefore cannot be trusted. I haven't seen much in the way of automated remediation. So SNMP, you basically get two options. Your first one is polling. I don't like polling. I don't like polling for the same reason I don't like active checks. The biggest problem with something that's not event-based is that you're at the mercy of whatever polling interval you have. In networking, it's generally not an awesome idea to poll more than every 5 minutes, depending on how far away your node is from your poller, and depending on what's actually on that node. A virtual chassis from Juniper or a Cisco switch stack, for example, is going to have a boatload of ports. And some polling solutions will try to poll every single port and get all of the data on every single port, and it will actually take it longer than 5 minutes. And that's on a good day. You take things like CPU into account, and you pull something at just the wrong minute, and it can take much longer than 5 minutes. It can also lead to some incredibly inaccurate data and a lot of false positives. It's not abnormal for me to see a polling mechanism report that a 10 gig interface has exceeded 20 gigabits of traffic, which is literally not possible. You can't do that. But because of the nature of polling and the way the math works out, it thinks it is. It's historical and performance data primarily. That's what it should be used for, and that's why it's not a super big deal, because that 20 gigabit spike, because generally speaking you're dealing with RRDs, that 20 gigabit spike is going to disappear. It's not going to move the needle enough in that one performance check for it to really matter. But the problem is, if you're doing alerting based on your performance data that you're getting via SNMP polling, you can get paged, and it's actually not a problem. It's happened for me a lot. Like I said, it's super unreliable. The other option you have is SNMP traps. And SNMP traps are arguably event-based. Something happens on a system and it generates a trap, and it sends a trap to a place that you tell it to send it. The problem is, systems that monitor for traps and can do things with traps tends to be incredibly expensive. I have not personally seen one that is free or open source or not stupidly expensive that actually worked even moderately well. I have actually built my own. So this is, personal journey thing. Yeah, did it. Wrote one in Perl, of all things, a few years ago. And what I found was you have vendors that, even though we have standard SNMP traps and standard SNMP MIBs, vendors implement their own garbage because they hate us all. I'm entirely convinced that every vendor is out to make the life of every network engineer completely miserable. We have no standards. Where we have standards, the vendors eschew them in some misguided belief that what they made was better and that it's somehow a value add for us. So SNMP traps, not cool. You can actually forward them to Nagios and have Nagios alert on them. It's actually really not good at this. Please don't do this. If you do this, please find something better to do. I've done this too, and it's not fun. Like I said, multiple vendors and even multiple platforms from the same vendor tend to present a problem. Even different code releases for the same vendor on the same platform can change things so drastically that everything that you've done becomes a moot point. And this is actually a recurring theme in pretty much every option available. Again, pretty convinced vendors hate us. Syslog's another option, but we're going to come back to this vendor interop thing again. You can have, even in the same operating system, running the same version, 2 different syslog messages. One might include the process that generated the syslog message, and the very next message might not. And it can become very difficult, frustrating, and infuriating to have to parse messages when, even if you're a single vendor shop and you're running the same platform and the same OS version everywhere, you write a parser and then it throws an exception and you start cursing profanely and doing all sorts of terrible, awful things because one message had the process ID, and then at some point, unexpectedly, you got one that didn't have it anymore. I know this because I've written a syslog file parser. I did not go down the route of writing a custom syslog server. I didn't really want that headache. I figure there are syslog servers that are out there. I should let them do their thing, and then I'll just read the file. Reading the file is not cool. Reading the file has all kinds of interesting caveats. If you're reading a syslog file and trying to parse it continuously, you've got a couple of options. One is to open the file and close it when you're done parsing, and then open it again when you need to parse it again and do it on an interval basis. And it's really CPU intensive, it's really ugly, it's hard to keep track of where you are in the file. The other option is to open the file and leave it open and try to read as events are written to the file. This works great, assuming you don't do something silly like try to leave the contents of the file in memory the entire time. You have to actually rotate the data out of memory, or you end up consuming all of your RAM and crashing your process, potentially your server, and not a good time. That sucks. The other problem is, even if you're reading the file constantly, if your process crashes for some reason outside of your control, and you restart the process, how do you know where to start back up in your syslog file that you're trying to parse data and get something meaningful out of it? You potentially miss dozens of events, maybe hundreds, depending on how active your footprint is. I have done this, I decided that it sucked, so I stopped doing it. I have one thing to say about streaming telemetry. Unless you're running 2 very specific vendors with some pretty recent code, you don't get streaming telemetry. And not even just specific vendors, but specific platforms on top of that. I am not the person that is fortunate enough to operate a single or dual vendor network or single or dual platform network. I have a multitude of devices, and while some of them support streaming telemetry, most of them don't. And I'm a pretty big fan of having a single way to interact with and manage my environment. I don't want to have these 10 routers that can actually do streaming telemetry and try to support this for what might be 5% of my entire footprint. I would rather fall back to the least common denominator and say, or greatest common denominator, and say, what are all of the things that all of my devices support uniformly across the board? You usually end up with SNMP, syslog, or active checks. And even active checks aren't really across the board. for a lot of the reasons that SNMP and syslog aren't really across the board, and it goes back to vendor interop. Active checks are also interval-based, just like SNMP polling. I hate them for the same reasons I hate SNMP polling. You have to initiate an SSH connection or some form of TCP session to the box to collect data from it and hope that, maybe it's like an ISR, and ISRs have traditionally pretty wimpy CPUs. And maybe you try to connect to it and check for something at exactly the wrong moment, and the CPU is pegged, and your check either times out or takes forever to finish, and then you get a false positive. I don't like false positives. Active checks also involve writing a lot of custom code because vendors don't like us very much. They report everything in drastically different formats, and it's really, really painful to have to parse that sort of data by hand. And it has to be done per platform. Even if you've got the same vendor, if Cisco's the best example in the world because they've got like 50 different operating systems, and even inside of the operating systems, there's like 20 million different versions, and obviously an exaggeration, right? But Cisco, if you've got iOS, iOS XR, and NXOS in your footprint, they all report everything differently. They're all configured differently. Their APIs are all different. You have to custom parse and custom write your code to address those things. Some things help with some of this. Napalm, for example, is a great way to manage connecting to and interacting with a device. Napalm does not support all of the things. It supports a lot of things, and it's fantastic, but not even all platforms support all of the things. NXOS, for example, the last I checked, didn't have support for get BGP neighbor details. Junos does, iOS XR does, I think Arista does, but NXOS doesn't. So even when you have something great like Napalm, you might have to fall back to writing some custom Python, or at the very least, writing a custom mechanism to detect the vendor and say, okay, what I really want to do is show IP BGP neighbor, detail, and then I want to parse all of this data out myself. So there's a lot of custom parsing, and again, it's per platform. Automated remediation is largely I/O bound when it comes to the network. Most of what you're waiting for is sending a command to a switch, getting a response back. Locally on the server, you're usually not doing a whole lot. Most of the work happens on the remote end. There aren't many existing options. I've actually been down the path of writing my own. It started with the custom syslog parser and involved writing a lot of Python, trying to tie things together a lot. It worked pretty well. Lots of multiprocessing instead of actually being asynchronous. I had to manage job dispatching. Job dispatching is an interesting topic. Do you dispatch your jobs using Redis? Do you do it with RabbitMQ? Do you do it with Kafka? Heaven forbid, do you try to use MySQL to manage your jobs? And people kind of laugh when I mention MySQL is a job dispatcher, but there is a company that is famous for using MySQL as a job dispatcher. They have a massive MySQL infrastructure. They have a ton of compute. They can afford to do something like that. And they've got a lot invested in MySQL. And that's exactly what they do. I tried the MySQL route just out of curiosity. It wasn't quite as painful as I thought, but having beefy masters is kind of important when those events start really cranking up. For me personally, I ended up settling on RabbitMQ for job dispatching, and it was cool. I didn't really want to manage the infrastructure for RabbitMQ though. So all of this comes down to me discovering and taking a look at SaltStack, and I had actually looked at it for networking much earlier this year and late last year, and I had actually found it lacking some of the things that I needed. That's actually changed significantly in the past several months. Most people here probably know a little bit about SaltStack, right? But modules are flexible. They're easy to write, and you can use any function that ships with Salt or that anybody else has written, and you can take that data and do something meaningful with it. Virtual lets you masquerade as something else. Famously, you get to use package.install instead of apt-package.install or yum-package.install. I have quite a bit of experience with Ansible, and Ansible still has not figured this out. That blows my mind. Chef has this figured out. I'm pretty sure Puppet has this figured out. Salt has this figured out. Ansible, you still have to write custom code to detect, and it's not even code, it's some weird thing where they tried to make YAML able to do if statements on its own, and it's gross and ugly. Ansible's really, really not awesome. I don't like it. Lots of people in the network industry do though. Surprisingly, it seems to be the most prevalent network automation solution. Yet they can't manage to grasp something as simple as what Salt has with the virtual function. Nor can they seem to figure out that having Jinja 2 everywhere is honestly a godsend. This is a pretty classic example, right? In Ansible, for example, there's a special YAML key called when. When is your if statement. With Ansible, you've already got to know Jinja 2 because you're going to be writing templates. Why do you want to learn 5 different ways to write an if statement or a for statement? Ansible takes it to the extreme. They've got like 5 different ways to do a for loop depending on what your data structure is. Salt, you write a for loop. Salt's event-driven. I talked a lot about why I don't like active types of checks, why I don't like things like SNMP polling. It's great for historical data. It's not great for actually alerting on things. With SaltStack, you can actually write custom events. So maybe Salt doesn't have an event you want to match out of the box. Write something that puts it on the bus and then write a reactor that will do something with that tag. You get to dynamically respond to events, which is the entire point of self-healing infrastructure and automated remediation. So real quick, I'm going to go through what the stack actually is. But before that, I did not come up with any of this. This is totally a case of standing on the shoulder of giants. There are some really fantastic people who have done some really incredible work that made my life a lot easier. It let me go from writing my own syslog parser and writing my own multiprocessing Python and writing my own OS detection and a whole bunch of other stuff to just leveraging Salt. Napalm is the first thing. I mentioned it in passing earlier. The biggest thing with Napalm is it gives me a consistent way to connect to and talk to devices. Not necessarily that it returns everything that I need in an abstracted way, but it abstracts the communication away completely. Napalm Logs is actually a syslog server that receives syslog messages, does its best to parse them based on some pre-configured, really boils down to regular expressions, and then it publishes them to a TCP port that's listening. And it ships with some really great parsers built in, but the killer feature, so to speak, is that if you need to parse a message that Napalm Logs isn't shipping, you write a YAML file. There's also a way to do it by writing Python, but at the most basic level, you write a YAML file. And then there's OpenConfig. I honestly laughed when OpenConfig first came out. I thought there's no way you're going to get a community of human beings to agree on data models. when vendors can't do it, when the IETF can't do it. But the IETF is a special place. But they did it. It actually has come an incredibly long way. And it has most of what you need for day-to-day operations. So I'm going to rush through the rest of this because I actually have a demo. So Napalm, like I said, vendor-agnostic communications. Most vendors are supported. It's got some built-in functionality. Most of the things support getting BGP extended neighbor details. Last I checked, NXOS still doesn't have that support. Napalm logs, I forgot to mention, actually translates to an OpenConfig format when it publishes the parsed message. When you write your own custom parsers, you're not bound by OpenConfig, but I would strongly encourage you to just follow the OpenConfig models, be a little bit consistent. So OpenConfig is it's a sort of community-driven working group that is attempting to formalize vendor-agnostic data models. OpenConfig doesn't, vendors don't all support OpenConfig. Even the ones that do don't support all of the models. So what you can get is some sort of translation middle layer that will take the OpenConfig data and put it into a way that your device can understand. So hopefully I have a demo to do. The demo consists of a vagrant environment. There's a salt master, there's one salt minion, and then there's 2 Juniper routers that are running. And those 2 Juniper routers will be configured with OSPF and BGP by the salt master. And then we're intentionally going to break the OSPF section of it by shutting one of the interfaces down and then watching as salt actually takes that interface and makes it less preferred in the OSPF topology. And in that way, what we will have is a network where it has multiple paths and a link instability does not impact the network for longer than it takes for a link to flap, send a message, salt to get it, and salt to take it out of the topology. I should have had this going before. My apologies for that. But the whole idea is you don't want to just shut the interface down. If you shut the interface down and it turns out your only other interface also is unstable for some reason, it might be better to have a little bit of an instability than it is to completely isolate a node. So what it'll do instead is raise the OSPF metric. And sometimes, this is largely use case driven, right? For you specifically, it might be better to just isolate that node completely than it is to have that instability in the network. And one day this will finish coming up. And then there's, the OSPF case is not the only possible case, right? BGP goes down and you want to do something because BGP went down. Maybe you want to just go ahead and completely drain that peer session until a human can actually look and see, okay, did it go down because of a maintenance? Did it go down because the link is bad? And you can take it a step further too. You can have, once you've detected this event, you can go, all right, well, I want to go ahead and do some stuff for my end user. I want to collect the light levels on the optics. I want to get the error counters. I want to get how many times the interface is flapped. I want to get all of this data, and I'm going to stuff it into an email or Slack message or HipChat or whatever your communication tool of choice is. And I want to go ahead and just send it to the user so that they don't have to worry about doing this initial investigation. If I get that data, I can usually diagnose why a link went down without ever having to log into the box. I can just open a ticket to the DC and say, hey guys, light levels are low. SaltStack's already taken the link out of the topology. Please just go replace the optics and let me know when you're done. Optionally, have Salt create that ticket for you so that you actually don't have to have that step where you have to open a ticket to the data center. So, real quick, I'm going to log into all the things, and helps to use the right command, right? I'm going to start Napalm logs because it's not actually running, and that'll be the thing that actually detects that OSPF went down and publishes the event, and then there's a reactor, and the reactor fires off a state. So I have that running. I'm just going to bring the proxy minions up really quickly because they're not running. And then hopefully they're up. Cool, so they're up. All right, so next thing is to actually configure OSPF on them. I wish that I had more time to actually step through all of this, but I don't. So what this does is it takes an open config model and it translates it into a vendor-specific implementation. That way, the model always stays the same. The vendor can change, but the way the data gets modeled is different. And we can go back and look at what changes are actually made because Salt is wonderful and gives us a diff, compared with something like Ansible where everything is a pain. So if I go look at my routers, I've got 2 OSPF routers, or 2 OSPF neighbors. If I look at my OSPF routes, I have 2 paths to reach the remote end. And that's the case on both devices. It's a very simple topology. There's 2 devices connected by 2 links. They're equal cost. You can ping across them. It works. So the next thing is to attach to the Salt bus and watch the magic happen. Entering config mode triggers a message on the bus, by the way. So I'm actually going to disable one of the OSPF interfaces to simulate a link flapping. And a whole bunch of stuff happens. And you can actually see already that the diff is to set the metric to 500. So lots of stuff happened, right? We did the config commit, and that shut the interface down. Lots of stuff. All right, so here's the OSPF message, right? So OSPF goes down, and it's got a whole bunch of message details. I use a reactor to fire off a state using this data, primarily which interface had the neighbor that went down. Once that's detected, I go and I look at the actual operational state of the device, and I do 2 things. I check to see if the OSPF interface is actually up, and I check to see what its metric is. And the reason I do this is because I don't actually want to indefinitely increase the metric until it can't go any higher. I actually want to just stop after I've increased it once. So I've arbitrarily said anything that has a metric less than 500 is something that hasn't had a metric remediation run against it. And that's totally arbitrary. In my environments, nothing would ever have an OSPF metric of 500. In others, totally possible. And then if the metric is less than 500, add 500 to the metric. If the metric is greater than 500, don't do anything. Box has already been remediated. We don't need to take further action. So what this looks like practically is if I now And just to show you guys, EM2 100 is down, right? Flag's down, cool. So if I delete the disabled on it and commit the change and quit, Salt's going to get all kinds of messages and see, okay, OSPF came back up, right? But it's not actually going to do anything to the box. It's not OSPF coming up that I care about. There's nothing for me to do in that case. It's OSPF going down that interests me. So if I look at my OSPF adjacencies, I've got my two adjacencies again. If I ping across, I can ping across. If I look at my interface that I previously had disabled, it now says flags up. So I know my interface is up. But when I go and I actually look at my route table, I now have only one path. By doing nothing on my end as a human, I have a system that will take an unstable link out of my topology. It prevents me from getting paged at night because I already know I've got multiple paths to reach the same destination. I'm not concerned about one link going down when I've got 6. And I know that I'm not terribly oversubscribed. I mean, there's lots of caveats, right? If you've got 2 interfaces and that's all you've got, and they happen to both regularly hit 50 to 60% utilization, doing something like this is going to do you more harm than good. Because sure, you took the unstable interface out, but instead you've now increased the load on the only remaining interface so much that it's going to stop dropping packets. So there are no silver bullets. Know your network, know your infrastructure, know how things are actually supposed to work. Right? You wouldn't just willy-nilly start restarting Nginx everywhere, I hope. Maybe you would. But yeah, so that's kind of the thing. The possibilities are pretty much limited by what you can imagine. One of the things that we're about to start working on, for example, is the ability for a server to come up, and some of our servers run BGP. So we're actually taking a significant portion of host provisioning from the network side out of the network team's hands, and we're handing it over to the systems engineers. So we're saying, hey, when you bring up a host, all you have to do is notify Salt that the host is up, and Salt will figure out how to bring up the network port. And if that host is supposed to run BGP, Salt will figure out how to configure BGP to that host. You don't have to engage us. You don't even have to let us know that you're doing it. We have enough confidence in what the configuration that gets applied is that we don't need any intervention from the network team. That frees up the network team, but more importantly, it makes things go a lot faster for the people who are doing our bare metal provisioning. It removes so many barriers and so many back and forths and so many requests for data that it's just a win for everybody. So next steps, vendor pressure is important. Some vendors have no API. We should make sure all vendors have APIs. Writing custom events for Napalm logs is absolutely on my list, and then hopefully contributing them upstream and having them accepted would be kind of cool. So that's pretty much it. Thank you guys for coming and sitting. Does anyone have questions? Yes?
Have you solved the less than 5 minutes polling interval with SNMP? I mean, you still need to gather statistics, or what kind of, in the event, reaction to syslog messages is nice, but how do you effectively gather statistics?
So there's 2 parts to my problem with SNMP. One is that I have worked at places, including current employer, where SNMP is actually used to generate alerts. That's the thing that really, really bugs me. For historical performance data, 5 minutes for me is mostly okay, for the most part. When it's not, that's when you get solutions like streaming telemetry or agents that can actually run on the box. And when you have a container that can run on the box, a lot of times that container can get the data a lot faster than trying to do it over the network. Excuse me. So the point wasn't to get rid of SNMP completely. Unfortunately, I don't know if that's ever going to happen, right? It's so ingrained in the way that we manage historical data that it just seems like it'll never go away. But the idea was to stop trying to use SNMP and really mostly historical data for generating alerts. Anyone else? Cool. Thanks for coming.